Welcome to Math with Mrs. Bibb. Today I will be going over how to factor a sum of squares. You will need the sheet of paper pictured to complete these notes. In the directions in Google Classroom, I'll tell you what page number it is. We've already worked on this sheet of paper, but you'll need it to complete the second part of the assignment. We're going to be filling in the box that's at the bottom of this paper, this box here, sum of squares. And hopefully you noticed when we did these notes that it said only in the set of complex numbers. Your first set of notes for this assignment was complex numbers. So now we're going to talk about how to take this binomial you have pictured over here, how to take this binomial and factor it using this formula for difference of squares, but modifying it a little bit into a sum of squares. So I'll get started with the three examples I need to do. Those three examples are going to go in this box. If you need more space, you can write all around the box. That's perfectly fine. But those three examples we're going to put in that box, if you will, please. Okay, the first thing that you're going to do when you're factoring a sum of squares is you're going to rewrite it as a subtraction problem. So I'm going to rewrite x squared plus 4 into x squared minus negative 4. And now I have a difference of squares. I'm going to use this formula over here. I have a difference of squares. I have a subtraction sign. 4 is in this list over here. It's a perfect square. And I have a perfect square, a variable squared. So I'm going to write down two empty binomials, one with a plus sign, one with a minus sign, and I'm going to take the square root of the first term, the square root of the first term, the square root of x squared is x. That answer goes here and here. And this work that I'm showing right here, I do expect to see. Now you don't have to put equals x, that's fine, because the square root of x squared, that answer goes in the first spot. But the work that I show here, I expect to see when you're factoring difference of squares, sum and difference of cubes. Taking the square root and the cube root is work that I expect to see on your paper, so please be sure to write that down. And now I'm going to take the square root of negative 4. Up until this lesson that we just completed, we would say that we cannot take the square root of negative 4. But since completing that lesson before this particular lesson, you know that you should rewrite this as, let me undo that really quickly, the square root of negative 1 times the square root of 4. The square root of negative 1 is I, and the square root of 4 is 2. So the square root of negative 4 is 2i. And that answer goes in this spot and this spot. So the factorization of x squared plus 4 is x plus 2i times the quantity x minus 2i. Let's go on to the next example. X squared plus 25. So I'm going to rewrite this as x squared minus negative 25. So please write the original problem. Please rewrite it as a difference of squares. Then we're going to put two empty binomials, one with an addition sign, one with a subtraction sign. I'm going to take the square root of x squared, that's x, and take the square root of negative 25. Remember, to take the square root of negative 25, it's the square root of negative 1 times the square root of 25. The square root of negative 1 is I. The square root of 25 is 5. So the square root of negative 25 is 5i. I do not expect you, when we actually do these for practice, to write all of this work here. But it would be my advice, and I would expect to see it right now in your notes, to write down all of this work that you see here. When we do this on our own, I don't expect you to write all that out. You can just have the square root of x squared is x, and the square root of negative 25 is 5i. But for now, just to get your brain used to that, if you will please write this work that's pictured here. And that's my answer. X plus 5i, x minus 5i. On to the next. Looking at question 3, 8x squared plus 72, I do notice something different about this one compared to the other ones. I do have a common factor. 8x squared and 72 have the common factor of 8. So I'm going to divide both of those by 8. And ignore that, I think I just typed that on there. And that would give me 8 times the quantity x squared plus 9. I'm going to rewrite this. This is a sum of squares, so I'm going to rewrite a sum of squares as a difference of squares. That is still 8x squared plus 9. Then I am going to bring down my 8, put 2 empty binomials, one with an addition sign, one with a subtraction sign. I'm going to take the square root of x squared, that's x, that goes in the first spot. And I'm going to take the square root of negative 9, which is the square root of negative 1 times the square root of 9, which is I times 3, which is 3i. So 3i goes in this spot and 3i goes in this spot. That's how you factor a sum of squares. A sum of squares will have an I in it. I hope that helps, and if you want, you could multiply this out and confirm to yourself that when you multiply x plus 3 times x plus 3i times x minus 3i, that you will get x squared plus 9, and then you distribute your 8, and you'll get 8x squared plus 72. So it really and truly does work. Have a wonderful day.